This video is an exclusive excerpt from our latest FSW webinar. If you're interested, the complete replay is available for free by following the link in the description. Have a nice viewing!
So welcome for this first webinars about friction stir welding of bus bar. We do that because we have more and more demand for bus bar, so that's why we decided to present this webinar. I will start by a short introduction about what is friction stir welding. So mainly for beginners. What is the bus bar market? Pro and cons friction stir welding. How to design a bus bar for friction stir welding, and I will conclude this webinar about how to quality control your bus bar to be sure that the quality is okay. Just one slide about Stirweld, and I promise is only one commercial slide. Who is Stirweld? We found Stirweld in 2017. We are 37 people, and our main product is this blue box. So it's a friction stir welding head for CNC. So you can plug this head on any CNC machine. So you can use your CNC machine for friction stir welding. And the main advantage for you is the cost is lower than a dedicated friction stir welding machine. And of course, you get exactly the same weld quality. So we have installed more than 70 head worldwide, and a lot of in North American and also Europe. And we supply the head, but also the tool, the process consumable, and of course we supply a turnkey solution as a part design, welding qualification, jig, and of course training on site online. Okay, friction stir welding process can be composed in 4 steps. Clamping, step 2, the tool, step 3, the rotations of the tool, and step 4, the welding speed. Today, we have 3 customers using every day our friction stir welding head for CNC to produce bus bar. And now we can go to the step 2 of this webinar about what is the bus bar market. As you know, we can find a bus bar where we have a high current intensity. So, for example, into aircraft, into car, railway, different defense application, shipbuilding, energy. So basically, you can apply, and we already apply friction stir welding in bus bar in these different industrial sectors. And now, what are the existing pain points for bus bar manufacturer? Generally, there are 4 main pain points. The first pain point is the risk of unscrewing. As you know, the most common assembly process to assembly bus bar is screwing. The problem is a risk of unscrewing, mainly if you have vibration into your application. There is a risk of unscrewing, and there is a risk of fire because when the screw unscrew, there is a gap. This gap is a thermal resistance that increases the temperature, and there is a risk for fire. Of course, by welding, we don't use screw, so there is no risk of unscrewing. So that is the first pain point. The second pain point solved by friction stir welding is to reduce the cost. Roughly, friction stir welding reduces the assembly cost by 3 times compared with conventional screwing techniques or brazing. Why? Because friction stir welding is easier and faster. The following pain point is the copper short edge. So Here there is an interesting curve where in here horizontal line we have the timeline, and vertical line we have the production in megaton of copper. So that this is worldwide, and you can easily find this result in internet. And so there is two important results. The first result is this orange line. That is the primary demand. So as we can see, humanity, industrial sector require more and more copper. Why? Because we use more and more electricity to replace oil and to reduce our CO2 impact. So that is the first point. The second point is, so in black and red, is the existing production project. So as you can see, we reach the optimum of this existing mining source of copper. And in green is the possible project for mining. So it's not sure, it's a possible project. But the second result is, so if we include the possible mining project, we'll reach a peak at just after 2030. So in fact, here we have a double problems, is more demand and less copper. So that is the best combo to get an increase of copper price. So of course, today and the past 5 years, the cost of the copper increase, but that is just the beginning. And friction stir welding, why friction stir welding is so interesting, is the only one welding process to weld copper with aluminum. So to reduce the impact of the copper cost on your product, you must use less copper. So you can replace by aluminum, but you have at a specific location, you must weld copper with aluminum. And friction stir welding is the only one process for that. And the last pain point is a perfect conductivity. So I will show you later. By welding, you have a continuous metallurgical material. So we have a perfect electrical conductivity. That is the definition of welding. Okay, so now some example of bus bar done by friction stir welding. So here it's first massive bus bar. So as we can see here, it's 10 mm thick bus bar. And due to the geometry, this bus bar cannot be done by bending. So the only one possibility is by machining, and we lose a lot of the copper. So here it's not clear, but there is a friction stirred weld here to weld the horizontal part with the vertical part. So that is the first application. The second application is what we call a complex bus bar. So here it's so we have two welds. So the first classic weld for bus bar is to assemble this axis onto this flat component. So of course for that we use a circular weld to lap weld to go through this flat sheet and to start to weld the axis under the plate. So that is very common. Now by friction stir welding it's possible also to weld together the two sheets here. And that is very interesting because as we have a complex geometry here, we must start from a square rectangular sheet.
There's still 30 minutes to watch. Access the full video for free by clicking the link in the description below. And don't forget to subscribe to our channel to learn more about friction stir welding.